Today, we're going to talk about a really wild theory, one that could completely change how we see the universe. It doesn't need new particles or weird new forces. Instead, it's all about a fundamental rule that might have been hiding in plain sight this whole time.
So let's start with a huge question, one that kind of flips modern cosmology on its head. For decades, right, we've been told that 95% of everything out there is, well, missing. It's some kind of mysterious stuff we can't see. But what if that's just not true? What if we're not missing anything at all, and we've just been looking at the universe with the wrong set of glasses? And look, this isn't just some wild guess someone threw out there. The architects of this theory are making a bold claim. They're saying their predictions aren't flexible. You can't tweak them to fit the data. They are, as this quote says, a mathematical necessity, an unavoidable outcome of one single rule. Okay, so why do we even need a theory this radical? Well, because our current best model of the universe, the one pretty much all of modern cosmology is built on, has a couple of, well, massive gaping holes in it.
Just take a look at this. This is what we think the universe is made of. Everything we can see and touch, stars, galaxies, planets, you, me, this screen, all of that is just this tiny 5% sliver. The other 95%? We give it cool names like dark matter and dark energy, but the honest-to-goodness truth is we have absolutely no idea what they are.
Just let that sink in for a second. The two main pillars holding up our entire understanding of the cosmos are complete and total mysteries. We spent decades and billions of dollars trying to find them, and nothing. Our equations work out, sure, but we don't know why they work. And that is exactly where the unified chronofractal field, or UCF theory, comes into the picture. The whole point is to just get rid of dark matter and dark energy entirely. It starts from a completely new foundation, one that doesn't need any adjustable knobs or, fudge factors to make the math work. So instead of inventing new kinds of stuff, this theory is built on just one beautifully simple rule. It says that on the most fundamental level, the universe has a perfect, self-similar fractal geometry. Like a snowflake, where the same basic pattern repeats over and over, no matter how closely you zoom in. This theory is suggesting the entire universe is built on that same principle. And this isn't just a fuzzy idea, it's a super precise mathematical statement. This one simple equation, the theory claims, is basically the source code of the universe. Everything else, the expansion of space, how galaxies form, it's all supposed to flow directly from this one line of code, with zero tweaks needed. The solution to that equation is just a single number, called nu, or nu. And this is where it's really cool. This number is directly related to the famous golden ratio. The theory calls it the fractal time exponent, and it claims that this one single constant is all you need to describe the entire large-scale structure of our universe. That's it. So, okay, we have one rule and we have one number. What can you actually do with that? Well, let's look at the theory's first major prediction. This is where the rubber meets the road, because it makes a claim that is falsifiable, which is just a sciencey way of saying it can be proven flat out wrong by experiments. And the process is, well, it's shockingly simple. You just take that fundamental number v and you spread its effect evenly across our three dimensions of space. That's the whole move. And doing just that gives you a precise prediction for the most important number in dark energy, a thing called W0. And when you crunch the numbers, you get a solid, unchangeable prediction. No ifs, ands, or buts. The theory says Yn has to be about negative 0.794. Now, this is a really big deal because the standard model of cosmology just kind of assumes this number is exactly -1. And here is where it gets really, really exciting. When we compare this prediction to the very latest data coming in from a survey called DESI, we see a direct hit. The theory's number for W0 lands right in the sweet spot of what we're actually observing. But then you look at the second parameter, WA, and there's a disagreement. The theory predicts a positive number, but the early data seems to be pointing in the opposite direction. Now, you might think a disagreement is a bad thing, but in science, it's actually fantastic. It's a sign of a good theory. It's making a bold, specific prediction that can be tested. Future experiments are going to tell us, for sure, if the theory is right or wrong about this. There is absolutely nowhere for it to hide. Okay, so that's how the theory tackles dark energy. But what about that other huge mystery, dark matter? Well, it has a radical explanation for that, too. This is a massive shift in thinking. The standard model tells us the universe is built on this invisible scaffolding made of weird particles we've never found. This new theory says that's just all wrong. There are no extra particles. The structure we see, the cosmic web, is a direct result of the geometry of space-time itself. It means we should stop looking for stuff and start looking at the very fabric of reality. So, all of this brings us to the ultimate test, the moment of truth for this entire idea. And the amazing part is, this isn't some future sci-fi scenario. It is happening right now. The Euclid Space Telescope is up there, making the most detailed 3D map of the universe ever attempted. And it's going to see one of two things. The standard model predicts a messy, random-looking cosmic web. But the UCF theory predicts something completely different, a beautiful, orderly, non-random fractal pattern, a lattice, repeating across the entire cosmos. And the theory even has a name for how this cosmic structure gets built, the chronofractal frieze. Yeah, it's a mouthful. The basic idea is that at these specific points on this cosmic grid, time itself essentially crystallizes. And that's what forms the galaxies and clusters we see today. It's a truly mind-bending concept. And this really brings us to a quote that just perfectly sums up the whole theory. For decades, particle physicists have been on this grand hunt for new particles. But maybe we've just been looking in the wrong place entirely. Maybe the answer isn't about finding new things, but about understanding the fundamental geometry of time and space. So, which is it? Is our universe a sort of cosmic accident filled with mysteries we might never solve? Or is it the beautiful, inevitable result of a single, simple mathematical rule? The Euclid telescope is about to give us the answer, and we are right on the brink of finding out if everything we thought we knew about the cosmos is about to change forever.